sometimes the rate determining step will be the second step. So in this case, our fast step is the first step and our slow step is the second step. So if we were to do this the same way that we did the last one, having our rate law be determined by our slow step, just the reactants, we would have NOBr2 and NO as our concentrations. However, if you notice, NOBr2 is a reactant here and a product in the first step, which makes it an intermediate. And intermediates cannot be in a rate law equation. So these do not go in the rate law equation. So what we're going to have to do is we're going to have to kind of work backwards. So these are a little bit more tricky than when the slow step is first, but they're still really easy to do. So let's write out our rate equals our rate constant and then a concentration. So if we're working backwards from the slow step, our reactants, we have to separate this into what made the NOBr2. And that is NO and Br2. So in this equation we see these two reactants are forming this intermediate. So if we were to break this intermediate down into its reactants, it's really NO plus Br. So now if we look at the slow step, these are our actual reactants, and these are the reactants that we can write in the rate law. So we have two NOs, so NO is second order, and we have one bromine gas, so Br. And that is first order because there's only one of them. So this would be our rate law for a reaction where the fast step is first and the rate determining step is second.